Hello everyone, welcome to today's Vitodens 100 B1HA, B1KA Troubleshooting Faults F2 and 18 online seminar. My name is Miranda Getling. I'm the Viessmann Academy Manager here in the US, and I just wanted to take this opportunity to welcome you today and thank you for attending. I hope you all are having a great Thursday so far. I also wanted to introduce you to your instructor today, who is Jay Sheldon. Jay has been with Viessmann for the last 5 years. The first 3 years, he was a member of the Technical Service Department before moving into his current role as the Academy Training Instructor. Jay has a master license, has been in the heating and cooling industry for the past 30 years, including holding job titles as General Manager, Service Manager, and owner of his own company for 14 years. Before Jay begins, I just have a few housekeeping items to go over with you. The first is that you will stay muted throughout the entire seminar. However, at the bottom of your screen, you should see a Q&A button. On the left, you will see the desktop laptop version, and on the right is the mobile device version. You can simply click on this and type in any questions you have throughout the entire seminar. Jay will be stopping about halfway through the presentation and at the end to answer any questions submitted, so feel free to pop them in there at any time. This will be recording and it will be posted to our video library, which is on the Viessmann-usacademy.com website. And once you're on that website, you can simply click in where it says video library in the header of the page, or if you scroll down, we do have that larger video library section that you can simply click into. This is what you will see when you are in that video library. And up top, we do have the search function. So you could type in Vitodens 100, F2 or fault 18 and it should populate. It will also be in that recorded online seminar section. And then also, since we do have a product specific seminar today, it will be in that Vitodens 100 B1KA section as well. And since this is part of our collaboration seminar schedule with the Canadians as well, so we do have the North America YouTube channel, so you can also check out any videos we have from the US or Canada on our YouTube channel, and that includes today's seminar. And you can simply go to youtube.com, type in Viessmann North America, and our page should populate. So with that being said, let's begin. Here is Jay Sheldon.
Today we're going to be doing some troubleshooting on the Vitodens 100 HA and KA models. And as you're going to find, they're fairly similar in most ways how they operate as far as the faults go as well. So we're going to be doing troubleshooting on faults, the F2 and the 18 fault. Just remember, these are for licensed trained professionals that come to these classes, so really not for the homeowners. So let's get started, and hopefully you can pick up a couple tips here and there as we go along here. Even if you learn one little new thing today, I feel like I've accomplished something. So I appreciate everybody taking the time out of their busy day. As we know, it's starting to get cold and your phones are starting to ring, and calls are starting to come in. So I appreciate you taking your time to spend it with us here today. So let's get started here. And what I'm going to do is I'm going to talk about the faults and go over different things here. And then we're going to watch a couple of videos that we made. So those are some of the videos that you can watch on YouTube as well. And please don't hesitate to ask any questions whatsoever. If I don't know the answers, I can always get them. But usually I create all these faults in the lab anyway, so I know quite a few of them. So what we're going to go over today is I always leave this one up, the requirements of combustion, because we always seem to tend to forget about the basics when we go to troubleshoot. So just remember the triangle. Not that this is going to be in any of the presentation today, but I always leave that up because even as myself, after doing this for a lot longer than 30 years, sometimes you start to think of the hard things before you even look at the easy things. So the other things that we're going to explain are your hard faults on this boiler as well as your soft lockouts. We'll discuss all the different causes of an F2 fault, as well as a fault 18. And you'll see what an 18 stands for, and just that alone might see on our boilers how all our faults coincide with our part numbers as well. So it's pretty neat how they do things here. If you do ever have to call tech support, which has grown leaps and bounds in the last few years, great group of guys working there now as I have left. So no more grumpy old man in the tech support. But anyways, if you do call, you will need the serial number, the model number of the boiler. And normally the serial number on the HA and KA, as you can see, is over here in the inside. So you do have to take the cover off, and it's right here on the inside. It actually says boiler serial number. So it's right there, and it's normally a 16-digit number. Tech support, if you didn't know, did get a new number this past year. So this is the new updated number. So if you had the older number, this is it here. The other great resources that we have is Pro Resources. I like this a lot. I use it quite often. Matter of fact, I was using it the other day when my son actually is in the business as well, and I was looking up something for the Vitodens. And I could go right here and go to current manuals and get all this here, current manuals, as well as any type of faults that you get. You have this fault code checker. And I saved this whole Pro Resources as a favorite to my homepage. On both phones. I have an iPhone as well as a Droid, one for work as well. And I save them on both phones, and I can open this up immediately. And if you know you're not going to have Wi-Fi on the job, you can actually save it, save that page, either it be the service guide or whatever you're looking to do. But they have a bunch of other neat things on this page as well. And as you did go into the Viessmann website, as far as the Academy website, you can go right there from the top tab up in the corner and go right to Pro Resources. And that fault code checker, as you'll see, is very helpful. You will see that there is a place to add just the fault code checker to your phone, which you'll see on the next page. I don't just save just the fault code checker, which is nice because if you do use just the fault code checker, at the end it asks you if you do want to see the manual for that product. But the other thing is I do have a lot of the historical products out there. So if I need to look up any of the old products that we sold in the past, all of that information's here as well as any information like VitoSpec is very helpful for engineering submittals and commercial application guides. And they also have some residential application guides here on that. So it tells you what circulators you might need or things to that nature, closely spaced tees or low loss headers. So this is what you'll see on the website here. And this is just showing you how to save just the fault code checker. I save the whole Pro Resources instead of just the fault, and then it looks like an app on your phone. And then you can open it up. We are making a video on how to do that. It should be up anytime soon now. We are making a lot of new videos, and I'm doing a lot on troubleshooting as well. So look forward to more of our videos coming up. And that should be within the next week or so for this, how to install this as well. As well as it shows you really quick in the one of our videos here. So like I was saying, just go over this again. Remember your basics: air, spark, and fuel. That's your combustion triangle. So sometimes we tend to forget that if we don't have enough air, you know, we're going to get a fault. So or not enough fuel, or if we're not getting a spark. So sometimes we tend to forget about that triangle we learned in our tech schools. But just to go over a sequence of operation for the HA and the KA, your heat demand comes on, your internal pump will start. Your three-way valve that's normally sleeping in the domestic side is going to go switch over to your heating. Your burner will start and modulate to the temperature. Once your demand disappears, your burner will stop, and then your internal pump will stop running after a 4-minute delay. And then your three-way will divert right into the domestic and sleep. For your domestic sides on each boiler, this is the way it will run. On the HA model on the left-hand side here, you're going to see that you have either an aquastat or a number 5 sensor or a domestic water sensor inside your tank. So that's going to send the signal over to the boiler, which is going to start the pump. And once it reaches its set point, the burner will stop, but your internal pump will run on a 30-second delay as well. On the KA model, just make sure that you need that 0.4 GPMs to get that flow switch activated, and then your internal pump will start. And once your flow or you shut your faucet off, your burner will stop. Same thing, your pump will run for about 30 seconds afterwards. Just to go over your low priorities and your high priority faults with the hard lockout or soft lockout. Say you get a hard lockout, which would be sort of like an F4 fault, or the F2 fault that we have going on today would be a hard lockout. So that means you'll have that triangle in the screen, as well as the R will be illuminated, and you have to hit the reset button to get that. Even after you make the repair, you still have to hit the reset button. Burner blocked, low priority soft lockout, that's going to be our 18 fault for today. That's a soft lockout. As soon as you make the repair, it will automatically correct that fault. As well as on this boiler here is one of the only boilers that we do carry that you do not need the outdoor sensor to run. You can either go into program and take it out, or just cycle the switch on and off. And that's what I noticed with this boiler. As soon as you power the boiler on and off, it automatically gets rid of that outdoor sensors and continues to run. But just be aware that our boiler does come defaulted for a fixed temperature at 158. So you will want to increase that if you're running any high temperatures. You might not have domestic, but you could still have heat as well. Just to show you a ladder diagrams here, this is about one of the only ladder diagrams in our manual. And as you'll see today that we've made new ones just for classes, so you can have to make it easier for troubleshooting. And so you'll actually be getting a copy of these ladder diagrams that we are making. So this just happens to be for an F4 fault, just to show you how the ladder diagram works. You know, if your fan starts or not starts, you go one way or the other. So it's a nice little way of troubleshooting. So that's what I find as well. And hopefully soon enough that we can have everybody come in and do their own hands-on troubleshooting as well, because I can't create all these faults on the boiler. So it would be nice if you could bring your own meters in, your own manometers, and do all this hands-on yourself. And we actually have 8 of these boilers in the lab if you haven't been there yet. And hopefully sooner than later, we can have you guys come in and troubleshoot these boilers. Not that you're going to see a lot of the faults, but what I like about Viessmann is you're going to find that they're very easy to work on. You can get to everything fairly easy to work on. Just showing you the burner sequence of operation here. And then as you can see how long each thing's run. This is copied right out of the manual, this part of the here. And then we just added these where you may get some of these faults on your boiler, just to see whereabouts it would happen. This bottom part is not in your manual. These are things that we create here for training. If you do get any of these faults come up on your boiler, this is what it's going to look like on your screen. So as you can see on the top left-hand corner there, you have the F2 fault. And on the top of the F2 here, you can see there is a triangle. And inside that triangle is actually a lightning bolt. And we've had that lightning bolt going way, way back on all our controls. Excuse me. Right next to it, you can see that there is an R now and it's illuminated. So that means that you have a hard lockout on that fault. You're going to have to go in there, fix the problem, and then hit the reset button. Right next to it is the other fault that we're going to be working on today. As you can see, it says F18 on the screen. And that is exactly how it comes up on the screen of the boiler. If you go to look it up in your service manual, though, you're not going to look up an F18, you're going to look up an 18. So that, I like to explain that, because even with myself, I was looking for an F18 and I had to go up on the manual and look at an 18 fault. So just be aware of that. So as I was talking about earlier, our sensors really coincide with our faults as well, with the number of the sensors. So as you can see, here's our numbers of these sensors. So our tank temperature sensor, our domestic water sensor, is always going to be our number 5 sensor on any of our boilers. Same as the outdoor temperature sensor. It's always going to be your number 1 sensor. on all our boilers, as well as our number 3 sensor. On 95% of our wall hung boilers, it's going to be the number 3. As you get larger on the 200s, you're actually going to have 2 number 3 sensors. And as you can see, to test these sensors, they're all 10,000 K NTC resistors, and that's kilo ohms. As well as our fluid temperature sensor is our number 15 sensor. So once you start learning our numbers on our systems, the faults are actually going to coincide with that number. So let's say on a tank temperature sensor, you got a 50 or a 58 or a 1 or an 18. As you can see, the numbers in the front here are 3, 10, 18, 1, and then 5 and 58 for a 5. And what do those mean? So if you had a 50, the 0 would mean that the sensor is shorted out or your wire is shorted out. And if you had an 8, the temperature sensor wire is broken. So that's the infinity symbol turned sideways. So if you had your meter on there. So that's a neat little helpful tool as well. As you can see here, here are our resistance charts that we do have in our manuals. So that's why it's nice to see the manuals and have the manuals on site if you can. That's why I always show that pro resources so you can have these sensors, because these are the way you test your sensors, by doing ohms test on them. On your KA model, you have either a flow sensor or your outlet sensor on it as well. Your outlet sensor is actually the same as your number 3 sensor. No difference at all, really. This is the same exact sensor. So if you kept one of those sensors on your truck, it would cover your number 4 sensor as well as your number 3 sensor. And this is, remember, it's only for the combi unit. Your flow sensor here, that's what's checking your GPM. And in that hole right there, if you ever take it out to clean it, never poke anything through that hole, because there's a sensor membrane in there that's sensing the flow. If you poke anything through there, you will definitely have to get a new one. So let's talk about the F2 fault to start with. The F2 fault, there's your fixed high limit, and that's normally what the fault code check is going to tell you, that you went off on fixed high limit, which will trip at about 210 degrees. Things that may cause your fixed high limit, we'll talk about that now. First thing I look at when I walk up on the boiler is what is my pressure at? Am I in the green? Because on these boilers here, it does show you a green marker there. That's where your water pressure should be. Don't be fooled by pressure gauges. Sometimes I always carried a spare Watts pressure gauge where I could screw right onto the boiler drain, just to double check the pressure gauges, because we know sometimes pressure gauges, not just ours, everybody's, will get clogged sometimes, not all the time, but it can happen. So we should be in the green, but double check that pressure. It's very helpful. Is my pump frozen? On these Gruffins pumps, on these boilers, there's a cap on it, as you can see on the left-hand slide there. That cap is for actually bleeding the pump when you install the boiler. So it does state right in the manual, before you start running water and starting the boiler, you should bleed the air out of that. And you could take that cap right off and have all your valves open. It's going to trickle out of there. Just have a little cup underneath there, get the trickleness out, trickle of the water out. So the other thing is, if you look right in the center of that, it's like a cross tip slot. Some of them are torque heads, some of them are a flat tip. But that's just to check to see if your shaft is frozen inside there. If these Gruffins pumps, if they sit around for a while, they tend to stick a little bit, and sometimes you just got to move the shaft back and forth, and that will free up the pump. But to do so, make sure you turn off the power when you're checking these things here. To test the power to the plug itself, we're going to pull the plug off the pump. put our 2 meter leads into the 2 outer holes here and set our meter to AC current for this test. So we're going to test with AC current. There should be 120 volts here. I took that picture of, that's right on the plug itself to how to take that plug off the pump. So you have to actually stick that screwdriver into the little slot to break the mechanism, and then you can pull that plug right apart. If you don't know that, you're going to be tugging and tugging on that plug, but right on the wire itself, there's that little picture diagram. And then just make sure you turn off the power when you're done testing. So that's your neutral and ground on your 2 outer wires. You should get about 120 volts there. What else could cause an F2? Clog in your system, a clogged flow check, clogged something out in your system. Your flow check, or in this case here, that's a spring check. Spring checks can get clogged up, or a solder ball stuck in them, or just partially open so you're not getting enough flow through them. Or even a heat exchanger can get partially clogged where you're not getting good transfer. That would cause an F2 as well. So to test the sensor itself, this is not a wet well sensor. This is sitting on the surface. The max temperature is 210. In the manual, it states that if you cannot reset the boiler when it's approximately about 203 degrees, replace the sensor. We're going to set our meter to audible, which on anybody's meter kind of looks like a speaker with volume coming out. You're going to set it to there, and we're going to check to see if the switch is open or closed. If it's open, that means we exceeded the 210. If it's getting a beep like you'll see in the video, that means that it's closed and it's working. But that doesn't mean that it's off. Sometimes they can go off. I haven't seen so much on these here, but I have seen sensors read at different temperatures. So that's you want to make sure you compare the temperatures of what you're getting. Put your test leads right here. So here's a little ladder diagram that we did make up for this part of the testing. So this is not in the manual. This is something that we made up for this class. So I thought did a great job on this as well. So it's just a nice little thing that, with these diagrams and things like that. I have a little notebook that I punch the holes in them and I carry them around. I guess I'm old school. But now with this video here, or this class here, you can go online and get this as well and just look at it. So this will be the video here. And this I did in the lab. So this is where you guys would come in and do it in the lab. So hopefully soon enough, guys.
Hi, I'm Jay Sheldon, Viessmann's Academy trainer here in the US. And today's troubleshooting fault we're going to do today is on the F2 fault on the Vitodens 100 KA and HA model. As you can see, we do have an F2 fault on the boiler. And now we will go to our Pro Resources and let's go see what an F2 fault will do and what the cause is and how we're going to repair the F2 fault with our Pro Resources fault code checker.
This is the neat thing about this fault code checker. Hopefully the music don't put you to sleep. As you can see, it asks you what boiler you're working on.
All right, first thing we're going to do is take the cover off the boiler. We have 2 screws on each side of the boiler. I have loosened them for this presentation. We're going to lift off the cover and take the cover off. Once we do that, we're now seeing the boiler itself. We're going to shut off our power on the boiler while we do our testing here. First thing we want to check is to make sure we have enough pressure on the boiler, which on our boilers we have this gauge here, and it shows you that you're in the green. If we're in the green, we're good to go. Next thing we're going to check is do we have air in the boiler. Our boilers do come with a bleeder on the top here. We provide you with a hose. I'm going to put the hose on the boiler here. Put it into your drain. And then with the key that we provide from Viessmann, we're going to make sure that we're completely air-free of the boiler. Once we do that, we make sure all the air is out of the system, and then we shut the key. Next thing we want to check on this boiler here is our pump itself. Our pump creates a flow, and if it's not creating a flow, the boiler might just shoot right up to high limit, which this is the fault for this boiler, is a fixed high limit, as we saw in the fault code checker. To do that, we're going to take the 2 tabs, squeeze them, and then pull down the control. If you don't feel comfortable with the water situation, get yourself just a cheap plastic bag and cover your control. That way we're not going to get any water on the control itself. I did take the liberty and cut a little cup in half. You're not going to get a lot of water out of the pump, but we want to check the pump because the shaft could be frozen or airbound. The other thing we want to check is for 120 volts at our plug. Next thing we want to do is remove the plug off the pump itself, and you're going to need a small screwdriver to do so. And you're going to stick it into the tab here, loosen the hold on part of it, and then pull it out. And what we want to do here is check for 120 volts. So we will have to turn on our boiler and check on 120 volts with our meter. We're going to stick it on AC current. Once we do that, we're going to now come up here and check for 120 volts, but we do have to turn the power on. And we're going to check for our power here. Once we do that, we now have the 120 volts or 118 volts in this case here, and we're going to the 2 outer parts of our test part. So we know we do have power here at our pump. So we can shut the power down once again. So we know we do have the 120 volts at our plug. So the next thing we want to check is to see if our pump is turning. And with that, you're going to need a larger screwdriver, like a 5/8 screwdriver here. And right here, a lot of people don't know, but when you first install this boiler, they ask you to take this cap and bleed the pump. Make sure that you're getting all your air out of your pump. Then when you look inside there, there's actually a shaft to hold your screwdriver. It could be a slotted screwdriver, or sometimes it's a torque wrench, depending on the pump itself. And you're going to turn it to make sure that your shaft is free of any debris, or the shaft is just not frozen. And as you can see, that small little cup is catching all the little water, but if you don't have a cup, a rag is fine, because you don't get a lot of water out of this boiler while you're doing this. And I do have all my valves open now to make sure that we're getting water into the system and bleeding it at the same time. As you can see, not much water at all. That's what you're going to find with Viessmann's boilers. You're going to find that they're nice and easy to work on and service. You can get to everything fairly simple. So far we've checked our circulator pump, made sure that there was 120 volts. We made sure that the gauge was in the green, so we had enough pressure on the boiler. And now we just checked to make sure that our pump was free and free of air as well. Next thing we want to check is our fixed high limit, which is up top of the boiler here. And by the way, all our plugs are numbered and marked, so we know which plug we're looking for. We're actually looking for this plug number 47. 47 here. And what we want to do here is make sure the wires are all good. Do a continuity check on all your wires if you would like. You're going to follow your wires down to your control and make sure there's no breaks or anything like that. The other thing is we want to check our fixed high limit itself, and it's just a basic snap switch. So on this one here, we're going to put our meter on ohms, and we're going to put it on sound, so we can hear it if it's open or a closed circuit. As you can see, the audible on your meter near your ohms. And what we're going to do is just touch each side of your snap switch up here. And as you can see, we're getting continuity through it. So that's telling me that the switch is good. If it was open, you would get no audible sound at all. For this class today, we do have an F2 fault. And by the way, if you have not, you get to the job site and you do not see that F2 fault, there's a way to see that F2 fault in fault history. Make sure you take a look at our fault history as well on the boiler itself, and we do have a video of that as well, so you can see that video as well. So we did find out now that the sensor is bad. It works, it doesn't work, snap switch. And what you're going to find if you do get there and you're off on an F2, the fan runs for about 10 minutes. So it's going to try to cool off the boiler itself, and then you'll find that the fan will shut off. But when you get there and the fan is running itself, you definitely know that it was went off on high temperatures. So for this here, we're going to take off your 2 wires, and you're going to grab either your torque screwdriver that you went out and bought, or our torque in our toolkit that you saw in the beginning of the presentation. This happens to be a torque 10 torque on this, so a T10. And there's 2 T10s on here as well. So we're going to take off the 2 T10 screws. And this is not a wet well, this is a dry well. So there's no need to drain any water out of your boiler itself. Your other ones do have are in wet wells, so you do have to drain the water out of the boiler. But remember, there's only a gallon of water on this boiler, so there's not a heck of a lot of water in here. Once we do that, we're going to get our part. And I took the liberty of getting the part before the class. Here's your part. Your part number is right here. And this does come with a tube of heat paste, as well as the part itself, as well as 2 new screws. So if you happen to lose your screws into the black hole on the ground where we can never find them once we drop them, they come with 2 new screws. You're going to take the heat paste, apply a fair amount onto the brass part of the, where the sensor is going to meet up. And I normally just spread it around, just so you'll get a nice heat transfer on there. So you can do it either way. You can put it on the sensor itself or on the thing. I just don't like to get it all over my hands. All right, so I do get the new sensor now. I have the 2 new screws. I put the heat paste onto the brass part of the boiler itself. And we're going to just put those on. The nice thing with our screwdrivers is they are magnetic. So if you do happen to get one for yourself, make sure you get the ones with the magnetic, so it kind of helps you out when you're putting it on. And make sure you do snug them up. You don't have to over tighten them, they're just holding it to the surface. Put your wires back on, your number 47 wires. That's the nice thing with our boilers as well, as you can see all our plugs are numbered, so you know where they go. So it's nice and easy, and you don't have to take pictures of where it goes, but hey, we've got cameras today. Once we do that, we put all our wires back on, we take our hose off here that we bled out the air out of. I did have our purging hose here as well. I had hooked on to the boiler. I do have isolation valves underneath the boiler, so I can shut the isolation valve. And I always purge on the left-hand side because we're forcing that water with the pump through there. And the nice thing with this boiler, if you didn't know, it has that purge mode on your in here that helps exercise the pump while you're purging, as well as the nice thing is it puts that diverting valve into the center position. Okay, so we put everything back together here. We're going to turn on our power. Goes through its test cycle while it's starting up. As you can see, now it comes on. We do have that F2 fault still here on the boiler. We're going to go to that R button, which is your reset button on this boiler here. As you can see, we have the lightning bolt as well. That's giving you a sign that there's a fault on the boiler. So all we have to do is press and hold the R button. It resets. It will reboot. And let's see if we fix the problem here. So now you can see it. Fault is gone. We're showing the inside temperature setting, as well as now we do have our outdoor temperature on here. So now we know the boiler's fixed and the boiler's up and running. But if you did, like I said earlier, if you do not see a fault on here when you get there because the homeowner happens to push the reset button, go watch our video on how to access our fault codes on this boiler and how to clear them. So before we leave any of our jobs, you guys want to check that. We'll hit the mode button and go to configuration or config on this boiler. Hit OK. I'm going to put 10 here. Hit OK. And as you can see, it stores our last top 10 faults. We have 2 here, and we're going to clear all of those before we leave for the next person that's coming to the job if he happens to know where to look for the fault codes, and you can take a look. They'll be all zeroed out. So we're going to press and hold them out. They all turned to 0, so now we cleared all the faults on our fault history. With that being said, I'd like to thank everybody for joining us for this brief, quick class on the F2 fault. Come again, and remember these classes are for licensed trained professionals. Thank you.
So that's just a quick little video, how to. So we're about the halfway point for this presentation. So at this point here, it's time to ask questions. If you do have any questions, please ask them. Get what you came for, get your questions answered, if you do have any. And remember that the only dumb question is the ones you don't ask. That's how you learn, that's how I learn, is ask questions.
All right, it looks like we don't have any questions at this point, Jay. Just a reminder, there is that Q&A. Oh, actually one popped in. So we'll go ahead with this one. So what is the most common fault and what is the best part to have on hand?
Depends on the boiler itself. On the KA model, what I had noticed in the earlier part of that boiler was the outlet sensor, temp sensor. They have corrected that problem, which was that number 4 sensor that I had talked about, which is the same as your number 3 sensor. So they went from brass to actually the stainless steel, titanium stainless steel sensors. And what they were finding was the chlorides in water were starting to attack those little brass sensors. So on that one there is a different fault. But as far as other faults, usually ones I had saw was like F4s were a common one, which I've done recently a video on that one as well. And you'll see there's a lot of different causes of that fault as well. But these 2 faults here, I have seen quite a few F2s. And that's usually what I saw with that was their water feeds weren't working. And the boilers were partial filled with water. And that's the most times I see an F2 is when there's too much air in the boiler and not enough water. And usually, even when I was in tech support, that was a common call, especially on a new install. What people tend to not see in the manual is that coding address number 1, and we do have a class on that as well. It's that first code that you come to in our coding. There's only 14 codes in this whole boiler. Is what they call your purge mode. And so when you go to that first code, it actually puts the boiler on and starts the pump for about 30 seconds and runs the pump while you're purging. So it helps push it, the air out through that round heat exchanger. So it's a very helpful tool. I talk about it all the time because it does work. I use it all the time. And then The nice thing with the 100s on new installs, your relief valves at the very top of the boiler. So if all, all fails, you can just, break the relief valve. It is new.
All right, great. Looks like that is the only question for now, Jay, if you'd like to continue on.
Awesome. Keep asking questions, guys. That's how I learn. Sometimes when I go to classes, they're asking me to be quiet because I ask too many questions. But I'm sorry, I'm a hands-on guy, and if I'm not doing hands-on, I ask a lot of questions. So it's a way it helps stick in my brain. So testing our sensors, you're going to set your meter to kilo ohms or K ohms. Some meters will automatically adjust to your ohm settings, but that's your ohm setting there. Looks like a horseshoe upside down. So for fault 18 or an 18 fault, this pertains to your outdoor temperature sensor. Remember in the beginning, as I was showing you the 18 or the 10 fault, remember the 10 fault was wires touching or your sensor is faulted out, shorted out, where an 18 fault is that your wires are broken or your sensor is broken. So to troubleshoot that, I always like to go over this because, sometimes we get lost with troubleshooting with wiring and meters. And it's never really explained properly when you go to school and all of that. So hopefully you pick up a couple of little tips here of me helping you set your meters to the right settings. To test this outdoor sensor, we're going to go to our X21 plug, which is that little white plug in your boiler. That's located right on the inside of the cover here. And there's normally one little screw right in here. I usually take that screw out so my old eyes can see these numbers here where your sensor is going to go. So as you can see, our outdoor sensor goes to 3 and 4 on that X21 plug. So normally if you're inside the building, you can just take that 3 and 4 off, set your meter to K ohms or ohms, and see what that outdoor sensor is reading. But remember, an 18 fault kind of means that your wire is broken. But we're going to check it anyway. So we're going to take the wires off 3 and 4. And if we do get an ohms reading on there, we're going to check on our outdoor sensor to see if our outdoor temperatures are jiving with our ohms resistance. So say it's 32 degrees outside. It should go up to this line here and then go across and get the same ohms reading that you're seeing out there. So that's how you check your outdoor temperature sensor. But what I always like to bring up is make sure that the outdoor temperature sensor is in the right location. We want to see it on the northwest side of your building, usually the coldest side of your building. We don't want to see it in the sunlight. We don't want to see it underneath a dryer vent as well as your exhaust vent that you just put in, because I've seen that quite often. Guys drill the hole for their venting, and then, hey, if we drill the hole, I can get my thermostat wire there and then hang it right above the exhaust pipe and wonder why the boiler's not working. It's fooling the sensor into reading that it's warm. So that's why I always like to bring that up. So make sure that it's jiving and make sure it's in the right location. So you can do it either two ways. So you can go outside if you're not getting any type of reading and twist your wires together outside. What I normally do is I've already taken my wires off the X21 plug on the inside, so I'll twist them inside, then walk outside to my outside sensor. And sometimes you got to grab your ladder. It could be up higher or whatnot, and then twist my wire, or then just test my wires from outside in. And if you're not getting any continuity, so you're going to test your, put your leads on from your meter onto your wires. Now you're going to set your meter to audible and see if you're getting continuity through your wire all the way around. If you're not, then you know that you got to start looking for a broken T-stat wire. And there you go. And I've seen that more than I want to see. Electricians drilling holes through walls. People have cut my wire many a time. But that's what you would be looking for. And just remember, with this boiler here, if you don't have the time to troubleshoot it, you can power on and off go into coding, take your outdoor temperature sensor out, and then just let it run to whatever temperature you want to run to. If you're running high temperature, you're going to put a fixed set point to your max temperature of 180 or 179 in this case. And that way, when you get a time to go back, if it's in the middle of the winter or whatnot, then you can go back and fix the wire. If you do have to change the sensor, there's your part number there. The other things I like to say is don't run your, if the outdoor temperature sensor wires are run next to high output line voltage, you might want to use shielded so you don't get any interference in your readings as well. And remember, you can't exceed the 116 feet of wiring. Again, we made you another little chart here for yours to keep. And if you ask questions, this will get sent out with those questions as well. Everybody gets, so if one person asks a question, everybody gets the question with the answer on it. So the more questions you get, the more I write in and then send out to you. I don't know who's sending them to me, so please ask your questions. I like helping people learn, so that's what I'm doing here. So here's our fault 18 troubleshooting video. If you make videos, you tend not to like to watch yourself.
Hi, I'm Jay Sheldon, Academy Trainer here at Viessmann, US. Today we will be doing a troubleshooting class on the F18 fault on the Vitodens 100 KA/HA boilers. As you can see on today's training, we're going to go over the F18. And what is an F18? We're going to go to our Pro resources and take a look at that is, and then we'll see what our cause is, as well as how to repair this fault.
Same thing on the fault code checker. You have to put in 18, not an F18. Because in the manual, it's under 18 fault, not F18.
So we do have an F18, so the first thing we want to do, and for this demonstration, I do not have an outdoor sensor, so we're not going to run outside and check our outdoor sensor. I made it convenient for us today, just so you can see how everything is done. So remember, we have the two screws on the bottom we're going to remove to take the cover off. Once we have the cover off, we can now shut the power off to our boiler. And remember, with the 100 is the only boiler that we do have that you do not need the outdoor sensor to stay running. You will get faulted out on the 200s, but it will still run and still show an F18 or an 18 fault. Nice thing with the 100 is as soon as you power the boiler on and off, it will actually take and see that we're not seeing an outdoor sensor anymore and automatically remove it, so your boiler will stay running. We get out there, and if the F18 is gone, we can go to our fault history once again and see what our fault was before we get here, or when we get here. With that being said, I do have our outdoor sensor just inside the boiler here. Just because in the lab we would have had one quite a few outdoor sensors to the outside, but for training, it makes life easier to work on it. So what we're going to do is remove our wires off our X21 plug here and remove them off the 3 and 4 on the boiler itself. So we're going to need our small screwdriver for this one here, as we saw in our demonstration in the beginning, what tools you were going to need for this fault. So we're going to take our wires off 3 and 4. And then inside our chart or in our pro resources, it will ask you if you want to see a manual itself. Right, so we can go into our manual or on our pro resources and see the manual there as well. We're going to look up on our chart for a fault for our outdoor sensor. There's actually a chart to test our outdoor sensors with ohms, and that would be killer ohms itself. So on this one here, we're going to take our meter and we're going to put it on ohms. Once we do that, we'll turn on our power and we're going to just go across our wires going out to our outdoor sensor. Remember, this could be 125 feet long, this wire going outdoors to your northwest side of your building. And remember, that's where we want to see our outdoor sensors, on the coldest part of our building, not under a dry event or anything like that, which we have gotten before. Once we do that, we're just going to touch our two wires together and read our ohms. And then we're going to look at our chart itself and see where we are with our outdoor temperature, as well as what ohms reading we're getting. Then we're going to follow that line across and see what we're reading, so see if it jives to the outdoor temperature. Once we do that, what we would do is, and we're not getting a reading, let's say we're not getting a reading going out, that could be a wire, so what we're going to do is go outside, take the cover off our sensor itself, take the two wires off, and then we're going to check and do a continuity check on our wires. So we're going to take these two wires off, twist the two wires together, and then go back and check your wire. And we're going to keep it on continuity. But this time we're going to take our meter from ohms and put it on audible, so we can hear to make sure that we're making a complete circuit through our wires. If that checks out well, and we know that that could be the problem, sometimes people cut the wires, we'll do another check with ohms reading on our outdoor sensor itself. Once we do that, we're going to replace the sensor with a new sensor, if that's the problem. But remember, sometimes we see it get false readings because we're either in the sun and we put it in the wrong location. And I've seen many guys put it out by their venting itself, because we already built the hole for the venting so we can get our little thermostat wire, and then hang it conveniently near a dry event or something like that, which is going to fool your outdoor sensor into reading incorrectly. So you might get different temperatures wrong with your boiler itself, and not heat or too much heat. So once we put our wires back together, put our new sensor on, put our cover on. Once we put the cover back onto the boiler, we're going to put our sensor back on number 3 and 4 on our outdoor sensor location. Remember, small screwdriver. Make sure you always pull on your wires. Make sure you're tight. Just a little trick that I used to teach all my people. Same with your wire nuts. Just a little tug on them. Make sure you got them in there good, because that can cause some headaches down the road, especially on your line voltage. Get those wire nuts on good. Now that we put the boiler all back together, we got our outdoor sensor on the outside, on our northwest side of the building. Let's start our boiler back up and see if we fixed the problem. Checking to see if we're getting our outdoor temperature coming back. There it came back. So now we do see that we're reading the outdoor temperature, which today is 75 degrees on the outside. This concludes our F18 fault on our boiler. As you can see, it was a little easier because I do have the outdoor sensor here. Sometimes we have it 8 to 10 feet off the ground on the outside, and we're going to check that. But I always start with pulling my wires off here to make sure that I do a continuity check or a quick test to make sure that my wires are not broken, because I'm going to go outside and test that anyway. So before I go outside, I twist my wires together, then go outside and pull the wires off the outdoor sensor, and then I just do a quick continuity check through my wires. Next, then I would put my meter on ohms and double check that sensor to see if our ohms is reading the same as what our chart is showing. With that being said, thank you for joining us here today for the F18 fault. And remember, these trainings are for licensed professional trainings. Have a great day.
So that was just a quick little video to show how to, and here's just another little quick video how to clear your fault history again. To me, it's important to do this for the next guy because especially on installations, you go do a new installation, you forgot to put your outdoor sensor on, you get a fault, or you faulted out on because you forgot to turn the gas valve on, whatever it may be, an OB fault because you didn't have enough water in the boiler and you're not getting any flow. Before you leave, just go to your fault history and clear it. And that way, this boiler here, like on our 200, gives you a time and date when the fault happens. This one doesn't give you the time and date. So it stores the top 10, it gets replaced, the oldest gets replaced with the newest to the top. But for the next guy, if he does happen to go out there and he sees these faults on there, they could be very old faults. So make sure you clear them before you leave for the next guy, or that way there's no faults on the history. So this is a very quick video, and then we'll be asking to see if you have any more questions. So this is very quick. I promise before I leave, I won't be saying.
Hi, and welcome to Viessmann's Academy Training Lab. Today we're going to look how to retrieve the last top 10 faults or faults on your code history on the B1HA 100 Vitodens. It's a very simple, easy, quick thing. Sometimes the homeowner might press the reset button before you get there. We might not know what the fault is when we get there. So there's a quick, easy way to check. So all we're going to do is grab our stylus pen, if you have one. I use a stylus because my fingers sometimes wander to the wrong buttons. So we're going to start by hitting the mode button until confi or configuration is flashing down here on the bottom. So we're going to do that by hitting the arrows. And now you can see confi is flashing. Once that's flashing there, we're going to hit OK. And now we're into password mode or programming. So we're going to go up to password for this one here is number 10. Once we get to 10, make sure you hit OK. And now we're at our fault history. And as you can see, our fault history, starting with the fault number 1, is the newest fault, is a 38. If we go up with our up arrow, we can now see that we've had an OB fault. And a lot of these faults, we do have videos that you can go watch to see how to fix those type of faults. And these could have been prior faults that nobody cleared before they left. And our last one here, we have another one, an F2 fault. And that seems to be all the faults we have on this boiler. So a lot of times when we're in training, I tell people, make sure before you leave, after you fix the problem, go in there and make sure that all your fault history has been cleared. That way for the next person that comes on the job, they don't see these faults, because with this boiler here, you don't see the time and date that it happened like you would on our 200. So all we're going to do on this boiler here is we're going to press and hold the R button. And you'll see all the faults clear. We go to number 1, as you can see here, we have 0, 0. So now we know all our faults have been cleared. So we fix the problem. We go in here, clear your faults, especially after your new installs, because sometimes we create a bunch of different faults. Like that OB is a flow issue, or it could be that had air in on a new installation, but they never went back and cleared the fault on the boiler. So make sure now that all the faults are cleared before you left, you fix the problem. We start with a clean, fresh page. We just back out of here and go to a main screen. So now we're back to the main screen. You can see that our boiler water temperature is about 122 here, and our outdoor temperature for today is 70 degrees. This concludes how to retrieve your last top 10 faults and how to clear them. Thanks for joining us here at the Viessmann Academy Training Lab. Hope to see you here soon enough to create your own faults and fix them yourself. And remember, these classes are for licensed trained professionals. Have a great day.
I'm not sure if you knew that was in there as well, but that's a nice little helpful tip. And if you had put these in the beginning, this was not in the manual. I happened to be playing around with these boilers for training, getting ready for a training class, and I stumbled upon this. So now it is in your manuals. And just remember that password to get into your fault history is number 10. To get into your coding, number 12. So we're at the end of the presentation here. I kind of went over your combustion triangle. Just remember the easy stuff. We tend to forget and look for the hard stuff first. Even when we're driving in our van, we're thinking about what the fault could be and what it's gonna, how long we're gonna be there to troubleshoot this fault. And sometimes we get ourselves all worked up, and by the time we get there, it's a simple, easy fix. So try not to think about the fault when you're going driving there, because sometimes it can drive you crazy. Take it from somebody that's been doing it for a long time. Put some nice, easy listening music or whatever you listen to and drive to your troubleshooting, and worry about it when you get there. So at this point, we're at the end. Please ask any questions that you do have. Make sure you get any answers that you come for, even if it's an installation question. Oops, sorry.
All right, looks like there are no questions at this point, Jay.
Okay, great. That means you learned something, or you know it as well. So that's great. I'm glad you'll find that the more you work on these boilers, the easier they become to work on. As I started with mercury relays and mercury switches, which are well outdated by now, so it's all electronics. So you'll see that these are easy, and they're newer ones that will be coming out within the next year or so are going to help you troubleshoot even more. And send a text to your phone and let you know that there is a fault on these boilers. So we've got some exciting stuff coming for the future as well. So stay tuned. Stay tuned for our new trainings that we have coming up as well. And we do have a bunch more troubleshooting coming up. So thanks for attending, people. I appreciate you giving up your time to come and watch this quick training here at the Viessmann Academy. Thanks again for joining us, and thanks for Miranda for all your help today.
Thank you, Jay. Just before we close out, just a few reminders. This will be recorded and put on the video library and the YouTube channel within the next 2 weeks or so. If you do have additional questions, you can email us at the Academy email. Jay, would you just mind going to the next slide so we can put that on the screen?
I was in control today.
No problem. So the academyus@viessmann.com email, you can answer, submit any questions you have. We are going to be putting together a document of any questions asked in this session and the one that we had last week. So we will be able to include that if you think of something afterwards. We will be sending you a PDF of the presentation and that document, as well as the diagrams that Jay showed today with the faults. So the ladder diagrams you did see before each video, you will get a copy of those as well. So keep an eye out for that email. And with that being said, just if you haven't already, go check out what webinars we have coming up. Next week, we have managing multiple temperatures and the application and piping of condensing boilers. So feel free to go and register for those online seminars at any time. And with that being said, that does conclude our seminar today. So have a great rest of your Thursday, and thank you again for attending.
Yeah, thanks everybody. Remember, these classes are free and knowledge is power. So come again. Thanks.